Hey everybody, in this video I'm going to go through setting up the computer flips in the uh, Google Docs, Google Sheets to solve using OpenSolver. I put down at the bottom, I kind of split my window here so I can see all of my equations that I need to use down at the bottom of the screen, and then this is the computer flips video demo, is that what I named it so that I can keep track of it. This is my Google Sheets. So the first thing we want to do is make sure that we kind of tell ourselves up in the top left, this is the computer flips problem. And then over here, we're going to start filling in our information. So our decision variables, we're trying to decide how many of each of the two different kinds of computers to make. So this is our simplex computer, and then in X2 is our omniplex. Right? Decision values, these two numbers don't matter at all. I usually just start with some 1 and 2 or 5 and 10. It really doesn't matter what numbers start in here, but you want something that you can kind of know what the math is going to be so that you can make sure your formulas are correct, right? The objective function is next. That's our profit, right? The objective function is going to be how much money would we make per computer, and then the total profit would be if you multiply that by how many of each computer you make. So if I make 2 simplexes and 10 omniplexes, how much money would I make? So first of all, I make $200 for each simplex. My profit is $300 for each omniplex. So what the total profit is going to do is multiply the 2 times 200 plus 10 times 300, add those together, and tell me my total profit. The formula for everything in column D is always going to be the same. It's going to be the decision variable value times the number below it in the row you're in, the objective function, plus the next column, the number of the X2 product times the 300 that you make for each one of those. $3,400 makes sense because you'd make 400 for this one, 3,000 for those, that'd be 3,400. And then we go down and list our constraints. So our first constraint here is our install time. The install time is how long does it take to make one simplex computer? It takes them an hour, 60 minutes to make a simplex. It takes 120 minutes to make an omniplex. What would that add up to? It's the same formula in column D always, right? Number of simplexes times the install time for simplexes plus number of omniplexes. Number of omniplexes times how long it takes to make those. That would be 1,320 minutes. And then on the right side here, we need to put down what our constraint limit is. They said that they had 5 people working 8 hours a week. So 5 people times 8 hours a week, and it's in minutes, so times 60. Right? We want to put equals in front of it, so it does the math for us. That would be 2,400 minutes. Right. Constraint number 2 is going to be the maximum number of simplexes. Remember, they did some marketing. So the maximum simplexes is 20, right? So it's got to be less than or equal to 20. But what kind of formula do we do? Well, every simplex counts as one simplex against that total. But the omniplexes don't count against the total number of simplexes. So a 1 and a 0. And then you do the same math here. So equals number of simplexes times the row we're in, plus the number of omniplexes times the row we're in. Right? 2 simplexes would add up to 2. That's less than 20. It'd be okay at this point. Constraint number 3 was the maximum omniplex. For that one, omniplexes count as one omniplex. Simplexes don't count as a simplex, as an omniplex, so a 0 there. And then it's the exact same math. Now, if you're getting tired of putting in that same formula, you can drag down, you can fill down, like we learned about earlier in the year, if you set up the formulas correct. So every one of these formulas is multiplying against row 4 times the row we're in. So if you looked at one of these formulas, it's row 4 times row 9. The next one is row 4 times row 10. This one should be row 4 times row 11. But if I drag down, that won't work, right? If I drag this down, if I fill it down, this one will move both of those down a row, and I don't want this to change each time. So how do we prevent that? Well, that's where we put those dollar signs in to say it's an absolute reference. So put a dollar sign in front of all the 4s in your formula. And if you fill that one down, or go to the bottom right corner till the plus sign shows up and drag it down, you'll see for each of those, it will put in 4. That's 4 times row 10, 4 times row 10. The next one, same thing, 4 and 11, 4 and 11. The next one, and it would keep going. Right? So we have one more constraint to worry about, and that's the testing time. They found out that they were getting a lot of returns, so they need to start testing the machines, make sure they work correctly before they sell them. So it takes 20 minutes to test a simplex. It takes 24 minutes to test an omniplex. Let's see, so we can make up to 16 of the omniplexes. And then for this, we had one person that was going to work 10 hours a week, 10 hours, and then times 60 minutes in an hour. So now our spreadsheet is set up correctly. We're ready to solve it, right? And it's a good idea to double check these numbers. Like, what if I changed this to a 10? All the numbers that should get bigger, get bigger. If you change that to a 1, all the numbers that should get smaller, got smaller. So everything's working correctly. I'm going to make my window a little bit bigger now so that I can see all of my solver. And I'm going to go into my add-ons, down to Open Solver, open my sidebar. So you want to make sure that this is on the correct sheet, and then start filling in the things. So the objective cell comes first. Our objective is to make money. This is the cell with the money. So we'll click on Total Profit. We'll go over to Objective Cell and click Update. The second thing to do is to make sure that the objective sense is to maximize. We want to make as much money as possible. If you leave that on minimize, it will make everything just 0, because the smallest amount of money you could make would be to not make anything. So let's see, variable cells come next. The computer should only change 2 numbers by putting numbers in. The rest are all formulas. These 2 numbers you want the computer to change. So we'll go to variable cells and click add. It's going to change B4 to C4. Right? And then next are to put in our constraints. Now when we first started out, we were kind of clicking on one and then the other, clicking on one and then the other. One of the things we talked about on Monday was that you can set up all of these things to be less than all of those things, and the computer will kind of match them up. So select all of the left side constraints, click Update. Select all of the right side, click Update on the bottom. So D9 through D12 should be less than F9 through F12. Those numbers should match up, and we can click Save. And then we can go down and click Solve Model. The other thing we should think about is it okay to have a decimal? Could we have half of a thing? And in this case, the answer is yes. We could have part of a machine that we would finish one week. We would just finish it the following day. Everything doesn't have to be done the exact same time. So it's okay to not add an integer constraint. If you wanted to add an integer constraint, you'd put the thing that had to be an integer, which would be our decision variables, and then we would put this on int to make sure it was an integer. But it's fine this way. So we'll click Solve. The computer will do the math. It's going to try different numbers, figure out that the most money you could make would be if you make 15 simplex, 12 and a half omniplex, which would be $6,050. Right? So that's the correct answer for the two product problem. Right. In a minute, I'm going to record another video for the four computer problem.